Thank you, ma'am. So, good evening, everyone. Respected our Dean Research Sir, Meenakshi ma'am, and Junali, and other faculty members that are present. Also, good evening to my dear students who have joined in. Although you are in computer science department, still you have interest in the power and energy sector. So I am very happy to know that fact. Also, some of my electronic students have also joined. So, with this, I will start my topic. That is, my topic is artificial intelligence applications in power and energy engineering. So, let me share my slide first. Okay. So, if you see the use of application, use of artificial intelligence in our various fields of engineering, science, and every other fields, you will see that nowadays artificial intelligence is like something like we are using in our daily life. Like everywhere you see, every social media or any site or any project, any device you see that there is some application of artificial intelligence in that area. So, among the various discipline of engineering, one of the most, we can call it as useful area of engineering is your electrical power and energy sector. So, as you know that if you go to the studies, that you will find that electrical engineering is the highest level of research and innovation that has been done in our 20th century work. If you see, electrical engineering is the most that we can say that innovative or most good, or in a sense good discovery in our research domain. But if you go to 21st century, that is only 20 years has been completed, you will say that artificial intelligence is the most innovative research topic we are concerned about. So there are fields that artificial intelligence has been applied, but in electrical engineering or in power and energy sector, if you see that there are also various fields of AI that has been already applied in power and energy sector. But if you see who are exactly working in that area, you will find very few people of computer science that actually working in that area, because we thought, we whenever we talk about electrical, we thought that that may be some other type of subject or other discipline that we are going to study, then we can only apply AI. Although we have the knowledge of AI, we thought that there is such situation that we have to study electrical engineering in detail, then we can only apply the AI wherever it is necessary. But if you see exactly where and what topics of AI has been applied in electrical power and energy engineering, you will see that there there is a very less requirement of an professional of electrical engineering, and there is a more requirement of professionals of computer engineering or the experts of AI. Basically, the experts of AI, that basically most of them came from the discipline of computer engineering. So, considering the AI applications in power and energy engineering, if you see that mostly we call it nowadays we call it as smart grids. Previously we call it as grid, now it is smart grid. Like smartphone or smart TV, it is now smart grid. So what is smart about that grid, that previously we call it only a grid, now we are calling it as smart grid. So that smart came from your artificial intelligence, that whatever there are areas of artificial intelligence that has been applied in your grid, and the grid became smart, and it is operating in a most efficient way than it operated in the previous years. So in the last 2 decades, if you see, there are various applications of AI in your power and energy sector. Even if you want to work, we don't go have to go to the details of the electrical component. All we have to deal with is the data that has been acquired by different devices or any grid component there is present. Everything has certain data, and our work will start from there. Also we can do that part. Also, if you want to go to the details of the electrical component, you can go to the details of electrical component and work there. So one by one, about some of the topics of our artificial intelligence, i will I will talk about in this presentation. So we'll start with basic power system. If you look at the basic power system, you will see that
Alina ma'am,
previous,
put it
yes,
in slide mode.
okay,
Please,
okay.
and please a bit louder, ma'am.
Is
Thank
it
you.
not audible?
Yeah, audible. Just bit louder, ma'am. Thank you.
Uh, Okay. So if we go to the basic power system, you will see that mostly the basic power system that is previously there, it is composed of only three systems, that is generating system, transmission system, and distribution system. So generating system means whoever is generating the power. In our case, previously it was only either it is a fossil fuel, or it is a hydro power plant, or it is a coal mine, or this type of power only we have been used previous from last 3 decades before. But in last 3 decades we are using photovoltaic powers, also we are using wind powers. So these are the renewable energy sources that has been incorporated nowadays, but previously it was only hydro or coal or thermal power plants. Okay. So when this power is generated, this power will be then carried to your mm, user by transmission lines. So transmission lines here, you can see that these are the transmission lines, the long towers here. These are the transmission lines. So these transmission lines will carry the power to the area where actually people live. It is not like that the persons or the peoples are living in every area. So there is a gap between city to city or village to village or some area. So whoever will carry the power to the area where people are living or users are living, to where your power will be supplied, that is your transmission line. In our case, our this is our transmission area. When you carry the power from this generating station to your user area, then in your user area you will use distribution lines. So distribution lines here is from this area to this area. So three types of things was previously there: generating station, transmission stations, and distribution stations. So after that the user will get power. If there are industries, then the industries will get also get the power, or any one else who is using, they will get the power. So basically the basic power system was not so complicated previously. So they have designed their mathematical equations or algorithms for carry out the smooth conduction of power transmission and distribution to the user. But if you look at 2 or 3 decades back, nowadays there are various use of your renewable energy resources. And if you incorporate renewable energy resources to the power system, then there are various changes that will occur. And that changes should be managed to establish a good grid, or a that we can call as continuous power flow. So techniques or certain types of tools who can handle that type of changes. So that's where your AI comes in. So if we talk about the application of artificial intelligence in your power transmission system, this is basically one of the area that you can call it as we can use our artificial intelligence. Next is your next is your what are the components we have already discussed. The power system are of three components: generation system, transmission system, and distribution system. In transmission system also we have differentiated transmission systems. One is called AC transmission, second one is called DC transmission, which we will discuss some parts in our future slides. Next is our smart grid. So whatever we discussed is only a power grid, that there is the generation system, there is transmission system, and there is distribution system. But if you look at the today's power system, it is not just a power grid. It is a smart power grid. So what is a smart power grid then? Here, if you see that, you will see that here there is wind turbines that are generating power. That is some thermal power plant that is generating power. There may be some like your photovoltaic cell here that are generating power. So whatever power is generated here, you have to carry out this power to your distribution system, and from distribution system you have to give it to the individual user. Then you have to give to your, if any office funds you want to give, commercial buildings you can give, any industry or factory also you can give. Then you have to use certain system operator and control data center that will control all these aspects that is being used here. The incorporations of distributed generations, that is wind turbines and photovoltaic cells. Also the whatever amount of data we have, or whatever amount of signals, current voltage we have, you can use certain tools or techniques to control that. Whatever disturbances are occurring in the power system, you also want to control that. So for that control operation you can use AI here. It is not that only AI can be used. There are various techniques, but if you go to the literature and analyze, you will see that the most effective ones are the AIs. Whatever techniques is used in AI, that are the most effective ones. So we can say that our uh, AI is important here. Okay. So now is, as we have already discussed, what is basically a power system, what is a smart grid. So if you go to the details of the smart grid, basically it is mostly the management of energy and how, where the energy came from, that where the power is generated. So at the energy of today's world, you will say that whatever resources we have for our energy, like coal, oil, or natural gases, they will be last only for few years, like 50 years or 100 years. Then what will happen after that? Then you have to look for another source of energy, or who can provide you the energy. That's where your renewable energy sources came in. So renewable energy sources, mostly used ones are the photovoltaic cells and your wind energy. So that are basically, we call it as clean energy, because they are not generating any type of pollution or creating any problem to the environment. So we are calling it those energy as clean energy. So if you go to the energy aspect of your power system, then you will see that Energy is also nowadays called as a smart energy. We are not calling it energy anymore. We are also calling it smart energy. So, what is exactly a smart energy is all about? So, if you go to the smart energy, you will see the concepts like Internet of Thing, that is IoT, Internet Energy Internet, that we are going to see what is it. Then Industry 5.0, Energy 5.0, then Smart Grid and Smart Grid Plus. These are the terms you came across when you look for smart energy. So before going to the smart energy, we will discuss something about these terms. We don't need to discuss about Internet of Things because most of us know that Internet of Things means it is the interconnection of devices in relation to internet, where we are using internet to share our data or also our methods to control all the devices we are going to use. Basically, IoT is all about that. Then comes your energy internet. We'll discuss that. Industry 5.0, energy 5.0, all we will discuss. Now, if you go to the smart energy and electric power system, that is smart EPS we call it. Basically, it is represented with two factors. One is called smart grid, second one is called energy internet. So basically, if you go to what is a energy internet, you will see that these are basically the sources of electric power, the networks, the loads, and the humans associated with it. So energy participant maybe have nowadays it is not like government or any private companies has taken responsibility and they will produce some amount of an electrical energy and they will give us energy, then we will use it our in our home or industry or any residential or commercial buildings anywhere. Nowadays it is already changed. Everybody is now capable of generating energy. How they are going to generate energy? They are going to generate energy. They are going to generate energy through your renewable energy resource like photovoltaic cell. Then I am also capable of generating energy, and that energy I am going to use when I will have shortage of energy. And if after using those energies I still have leftover energy, then I also can supply energy to the companies who are interested to trade energy or to other consumers. So nowadays the term consumer is changed to prosumers, that is producer and consumer. If someone is using renewable energy or photovoltaic cell, that person is a prosumer, that is he's producing energy, also he is consuming energy. And we cannot just rely on only renewable energy, because in some way like weather conditions like cloudy days or at night you just cannot use photovoltaic. So you have to either previously you have stored energy that you are going to use or you have to depend on the power grid to supply you the electricity. So basically energy concept is nowadays it is changing from only consumers to producer and consumer. Now if you go to your internet of energy internet or internet of energy, that is EI, then if you see here, if you look at it, you can see that energy internet means there is a smart grid, and to that smart grid everything is associated, like there are commercial users, there are industrial users, there are household users, there are smart buildings, energy producers, energy traders, and the energy service producers. So all these things associated to smart grid, you are going to need some tools and techniques that is going to helpful to carry out your smart grid operations smoothly. And what are these techniques? That techniques may be cloud computing, maybe Internet of Things, maybe big data, maybe AI, and many other tools that has the capability to analyze, to judge, to optimize, or any type of decision making. So here is the main aspect of how AI is going to be useful in your power and energy sector. So that is called as your energy internet. Here every technique like cloud computing, IoT, big data and AI will support or provide their functions to carry out the smart grid operation. And what is the core here? Here your core is power. We are only transmitting, distributing and consuming the power. And it is all about your data or information. Similarly, here it is all about your power. Whatever you are doing to either getting the power or distributing the power or consuming the power. That type, that is the basic purpose here. Next is, for this you need one new generation of artificial intelligence. That is, whatever artificial intelligence methods as they are before, they will not simply provide better solution. You need some other expertise for your AI applications. Okay, so here AI will replace whatever human knowledge they are used previously in your power grid. It will replace those and it will carry out its own techniques or algorithms to power grids. Here, that new generation of AI is called as AI 2.0, which is basically used in smart power grids. Now, next is, if you look at the evolution of artificial intelligence, you will see that artificial intelligence is, it is now to be 70 years before it is uh, discussed, or some theories has been given, like different neuron models has been given, the Turing machines has been suggested. But if you look at the details of the AI methods that are given, that people thought was some new techniques has been developed, that some changes will occur or some new improvement will occur in technological field. But when they try to apply those techniques, that is between your 1960s to 1970s, they see that those theorems or those tools or technique is not actually working, it is failing. So whatever they developed, it did not work till 1970. There is no actual implementation of AI there. But in early 1970s, there are development of your export systems and solo learning methods that give some helpful theorems or techniques or tools for practical application. So some of the expert system and AI tools has been implemented in medical systems, chemical systems, geological systems, and other fields. But the development is not so like we can call as advanced, or it is very slow. So if you look at the early 90s, that how much AI has been developed, it is basically not so developed stage or not being applied by every field of engineering or science or any other field. But when you look at the late phase of 90s, then you look that there are various other techniques that has been developed, like your convolutional neural network has been developed, various types of boosting algorithms has been developed, support vector machines has been developed. And with development of this technique, what will happen is, initially some implementation occur and it started growing till 2010, and AI has been implemented in various fields of technology. So With the development of deep learning, big data, and cloud computing, those techniques' involvement in almost all fields of engineering and science has been observed. If you look at the literature, you will see that almost all field of engineering and science has been employing AI in their theories or devices or technologies, whatever is there, they are employing. And if you look at the 2010 to 2020, in the last decade, the growth is the increment is much more than the period of 2000 to 2010. So this is basically possible because new techniques or new artificial intelligence techniques has been developed. Now, if you look at the AI 2.0 technologies, you will see that there are various types of AI that exist: expert system, multi-agent system, computational intelligence, fuzzy logic, offset, machine learning. Then there is recommender system, robotics, and all that. But among those that stand out more is machine learning. If you see, you will see that machine learning is the most used technique of AI. If you study the literature, you will see that machine learning is mostly used in everywhere. So if you look at the machine learning techniques, there are supervised, semi-supervised, unsupervised, then there is reinforcement learning, then deep learning, then there is ensemble learning, and with those we do the statistical learning, then classification and clustering and regression. These are basically the ML methods that is used. And if you look at the evolution of machine learning algorithms, you will see that from starting from 1957 to 2001, these are all shallow learning. Shallow learning means you predefinedly find one feature and you give it to the learner, then learner will learn and it will either do the classification or regression or prediction or clustering, whatever you want to, they will do. But there is no concept that from the data, current data, it will learn something and it will modify. That phase happened after year 2006. Till now it is still modifying. So here comes in the concept of deep learning. So deep learning, although many methods has been suggested previously, but we did not have any type of hardware at that time to implement all those algorithms. So what happened is, previously whatever algorithms are there, they we just did not implement it. But in last decade, due to the evolution of hardware structures, the possible implementation of deep learning has been happening, and this deep learning algorithms has been, as I have studied the literature, in almost all fields of engineering, you will see there is application of deep learning. Okay. Now, coming to the industry 5.0, if you see that five that point we mention basically to show the levels, that is there is 1.0, 2.0, 3.0, 4.0, and 5.0. So if you look at the 1.0, basically the mechanization era, that is 18th century, then your electricity has been invented and discovered and many people worked on that, and that has increased some technical advancement in the field of science and technology. Also, after that, in 1970, when they developed a programmable logic controller, that is PLC, PLC has improved or incorporated much development. Like in every field of engineering and science, you will see one computing device is implemented. So, after that, that is your industry 3.0. After that, although network or internet has been developed in 1970s, but the useful of internet has been come to the limelight in the end of your 20th century, or we can call it a starting of your 21st century. And this also emphasized much more improvement in technology, that is mostly networking and cyber physical systems that has been implemented in those era. Now talking about industry 5.0, if you see that it is going towards the parallelization. Parallelization means the outcome will be much more than that was previously done, because we have techniques like advanced artificial intelligence and other techniques, and also we have much more improved hardwares or devices now. So that is basically your industry 5.0. 5.0. So why I am explaining these terms, because these terms are the responsible concepts for developing a smart grid or smart power grid. So now coming to the energy 5.0, previously there are energy 1.0, then 2.0, then 3.0, then 4.0. Now it is 5.0. So 1.0 you see the natural resources, 2.0 mechanical and thermal energies, 3.0 are the electrical energies, and 4.0 are energy internet, and 5.0 we are moving towards it. We are at now energy 4.0. So when parallelization occur, there will be much more improvement in energy. So we are going to basically towards energy 5.0. So now that we have a overall idea that what is going to happen in if we incorporate artificial intelligence in the power and energy sectors, then we'll discuss some problems of power system and some problems of energy system, where we will discuss that we can apply our what artificial intelligence. So one by one we will see that artificial intelligence, if you see, it can be used to prevent power grid failure, it can be used to prevent blackouts, it can be used to real time monitoring, for prediction, for power grid faults, for balancing the grid, for differentiating power system disturbances from actual disturbances. Then all these types of uh, problems are there where AI can be useful. So one by one we will discuss. First, going into the transmission line, you know that whenever you go, you see that there are phases of transmission lines or overhead transmission lines are there, which is always exposed to the environment. So there may be lightning, there may be storms, there may be snowfall or anything, and the cable will be damaged. So in that case, you have to see that if this type of scenario is happening, there should be certain method that will indicate that this fault is occurring. So you have to detach your power system from your main power system from your actual utility grid, then there will be no damage. To do that, you have to for detect those type of fault, and there are various methods that is they are for detecting those faults. But in those electrical equation based method or any theorem they are using, they have certain drawbacks like they have events like such that it will the current and voltage signal will look like it is a faulty stage while it is not. So how you are going to differentiate it? They are either using equations or using a threshold or using some overcurrent or distance relays. So in that case, what you can do is just collect the current and voltage data, whatever is there in the measuring unit, and you can apply a artificial intelligence method to detect those type of fault. And when you detect those type of fault, you can just send a signal to your circuit breaker, that breaker will operate and it will open and it will detach from the main grid. So that one function you can do there. Now the second is, here you also want to locate where exactly the cable break and in the ground. So for that purpose also they are using some method, but that methods are giving at least 10 kilometer or 20 kilometer of error. So to if you send one patrolling crew to the repairing of the transmission line, what will happen is you will see that you will see that they will move forward 10 kilometer, then they will move backward 10 kilometer, and there they will find some place there is a fault. But if you just record those signal that is already happening in your substation, you just take those signal and you give it to any artificial intelligence method, whatever I have tested, the location error is within 1 kilometer. Like you have to move forward 1 kilometer, you will find one location where cable has been break, or maybe you will move to backward 1 kilometer. If we are talking about overall methods using AI that has been given, even there are researchers that claim that I can found the fault within 1 or 2 meter, and they have also proved that it is happening. But there are very few places in your transmission line that actually AI has been implemented or used to locate those fault or detect those fault, because whatever relays they have implemented, they are already, the relay cost, one relay is around 5 to 15 lakh. So in transmission line, if you see between two transmission line at the two ends, there is one relay here, there is one relay here. Similarly, this line also connected to some line. Then this line also connected to some line. Then this line also connected to some line. So everywhere the relays are already in place, and many we can say that money and hours and manpowers have already been spent. So to replace those relays, we have to do it like that, one by one we can replace. Like if this section's relay has been degraded or it is already worn out, then it needs to be replaced. And during that replacement, we can suggest the AI methods. And if you suggest this type of solution to power grid of India, they will also take. But what they are doing is, if they are doing AI method for this one, then here it is the old method, conventional one, here conventional, here conventional, and it is not possible to remove all the relays all over India to implement AI based relay. So what I am expecting after doing the research for 7 to 8 years is, they are not going to replace all the relays at a time and use the AI based relay. They are going to use it one by one, and at certain point of time it will reach that all over India we will have only AI based relays. It is possible, but for this we have to wait. As you know that already some, not some, many resources and monies has been spent over all the relays. So this research will go on for some year. After that, maybe all the relays will be replaced. Now, if you go to the signal, you will see that when a fault occur here, at this point, a fault has been occurred. So previously, this is your signals, and when fault occur, the current magnitude start increasing, and the voltage magnitude start decreasing. It will decrease. So you have to take those things and you will design your own method. Till now they are using their equation based method, you can use artificial intelligence based method. And it is always that what I have shown here is the clear signal. It is not. Sometimes it will be, signals will be like this, it will be near to your normal situation, and you have to use some kind of signal processing or something to carry out it. Okay, so this is basically one problem or one type of problem domain you can work with. Now second problem is the direction estimation. Direction estimation means, suppose you have a fault here. This is basically a line diagram of a power system, and here is your boss, here is your end, and here is your end. That is, you can get measurements from here. And if a fault is here, changes will also occur here. So how you are going to discriminate that fault has occurring here, but due to this fault some changes has been occur here, but the relay placed here no need to operate. That is also one problem. You can use artificial intelligence method to do that, or any other method, but I would suggest artificial intelligence method because it will be very easier to do that. But they are using equation based methods or the impedance resistance and inductance measurement, then comparing to something, then getting the result. Now there are, like your AC transmission line, there are DC transmission line. DC transmission lines are mostly used for transmitting your long distance power, and it is very useful for carrying out your long distance power. AC transmission lines are not capable, but the problem is more severe in DC transmission line. There is nothing there you can, if you take the measurement, you cannot find anything. It is just a straight line. Whenever a fault will occur, it will show you some changes in current and some changes in voltage, but that changes is only for one cycle, that is a few millisecond, that is 20 millisecond or 15 millisecond. And within that time you have to design one of the AI methods you want to design for smooth conduction of detection of those type of fault. So this is one problem you can work with. Only you have to take this, only you have to take this, and you have to design one AI method to detect the fault in HVDC transmission line. Many works has been done, many works has been done, and many researchers suggested many things, but still there are problems, like sometimes this signal that is I have shown clearly, it is not so clear, it will be like this. So what are you going to do in that scenario? And this voltage that is showing so smooth, it is not like this, it will be like this. So what you are going to do? So in that case you need signal processing as well as AI, both you have to use. Similarly, there are distribution systems. In distribution systems, you will see distributions means the lines you see outside of your home that is connected to your home, that is your distribution lines. That is, the line's length is within 10 meter, 10 kilometer or 20 kilometer. Not long lines are used for distribution. So similarly, in distribution lines also faults occur, and when faults occur, you have to detect those faults, you have to clear those faults so that power flow can occur. Here also you can take the measurements here. These buses where the measurements you can find. In each bus, you can find your measurement, and you have to take that measurement and you have to detect what is the disturbances occurring in this line. So this is one field where AI can be useful. Now, islanding. Islanding is when you incorporate your distributed generation, that is either wind farm or any solar power plant. What will happen is, if by any means your power system is disturbed, this circuit breaker that connected here will be open, and this system will run as a single unit by providing electricity to whoever is present in this distribution line. So what will happen? There will be problem because the system is completely imbalanced, still it is providing electricity because there are distributed generations attached. So that is called as islanding. It is detaching from the main utility is here, and it is detaching from here, then it is working as a single unit. So you have to detect when your distributed generation is working normal condition or when it is in islanding mode. For that, here you can use one classifier like artificial intelligence is there. So 0 and 1 is output, means you can use any type of machine learning algorithms there. So that is basically your distribution system. Similarly, there is also smart home management system. Smart home management system means whatever you are using in your home, you have to monitor that You have to, if you are using photovoltaic, you have to store, you have to use some certain types of app to manage your home's appliances and all that. So here aim is basically minimum cost, comfort and monitoring of devices. So here renewable energy, if you are using, that is one component of your smart home. Similarly, some countries are using electrical vehicles, that is also one. And you are using battery for storage, then you are using appliances, and there are also sensors and meters and everything is there. So the smart home network is basically you monitor, you analyze and you apply, and then you forecast how much energy you require. So basically that is smart home energy management system, where AI came in here. AI will came in analyze part. Here in analysis, you can use any type of artificial intelligence technique. You have device, you have data, you need to analyze the data, and after analysis, you can apply and you can forecast how much energy you are going to need. So there are various types of analysis technique like NN, fuzzy, and FIS, classification and regression trees, then expert system, deep learning, there are optimization techniques and many things are there we can use. Similarly, one of the extension of your smart home is your building energy management system or neighborhood energy management system. If you are employing multiple photovoltaic set, your photovoltaic in your neighborhood, then you can create a neighborhood energy management system or community storage to store that energy you collected. And for that you can use cloud and big data and IoT for the management. So among those energy efficient building, you know that 20% of the global energy is mostly consumed in your buildings. So it is important that you manage your building energy. So it is important that you manage your building energy. So to do that, there are various types of parameters are there. Like for a energy efficient building, most important one is the heating, ventilation and air conditioning, we call it HVAC. You need to control your lighting system, that is also one aspect of energy efficient building. How you are going to find the parameters responsible for heat, ventilation and air conditioning. Then you are going to take those data, then you are going to optimize or classify or predict any type of loads or occupancy using those AI methods. Similarly, you also need to control your lighting system, that is also one aspect of your energy efficient building. Similarly, there is one new concept that is been there in last one decade, that is net zero building, net zero energy building. What is net zero energy building? Whatever energy you are producing should be equal to whatever energy you are consuming. Like in night time or cloudy time, you don't have your photovoltaic, you cannot use that, and you either use your storage or use from the grid. But in your daytime you can use your photovoltaic. So whatever energy you are storing, it must be equal to, that is there should not be energy that you are taking from outside, it should be balanced. That is you are called as net zero energy building. And how you are going to do that? To do that you need a good controller, and whenever a controller aspect come into your technology, that means artificial intelligence can be used there. So net zero building also you can use artificial intelligence. Similar, to estimate the heating and cooling load of a building, also you can use your AI techniques. You have to first find out the parameters that is responsible for heating and cooling load. Like in India we don't have a uh, cooling load, we have a heating load, because most of it we are generating a heat and we are using ACs to for cooling purpose. We are not using AC for heating purpose. But if you look at the cold countries, they are also, their AC are designed such that they are using it for heating purpose also. So heating load and cooling load management is also one aspect of a smart building. Next is your occupancy detection. Another aspect is you must detect how many people are exactly using what much of a time in the of the building energy. So for that you have to employ various sensor. You just cannot install any camera inside all of your occupants building. So you have to use other means to find out your energy usage. So what you have to do for that, you need to install light sensors, humidity sensors, temperature sensors, and they will give you data. Then you will use artificial intelligence to find out if the room is occupied or not, and again, if occupied, how many persons are there. So whatever I have done in this field, I have done some work that I have found out there are not so many work that has been done that someone can say that exactly how many persons are there inside the room. It is always an average. So in this aspect also you can employ sensors, you can take the measurement, and you can work on those. What maybe you will use some technique to find out the exact occupant of a room. That will also provide one aspect to control the building energy. Next is appliance energy. Appliances also consume energy. So for appliance, you have to employ the sensors to measure your temperature, your humidity, CO2 level, occupancy, and energy consumed by appliances. Then you use some AI techniques. Then you find out the appliance energy. In India, we don't provide any energy estimate or power estimate to our provider that will need that much of power in our next month. But in many countries they have systems like that. You have to give an estimate how much power or how much energy you need for your next month, and when that much of you consume, after that you will not get anything. You have to give another estimate, or you will take you will arrange somehow how you are going to manage. Next is your electrical vehicle. You know that nowadays electrical vehicle is used by many countries, because what is the need for electrical vehicle? The need for electrical vehicle is your internal combustion engine based vehicles cause air pollution, global warming, greenhouse effect, then increase the temperature of earth, also damage the ecosystem. So you need a substitute. One of the substitute is electrical vehicle, because it is clean, efficient, and environmental friendly. Also, if you go to the detail, you see that it don't have a tailpipe emission. Also, its cost is very less per mile, but it will take many hours to recharge, and its range is a bit low. But if you look at other engines, you will see that their mileage is good. Also, they will only take a few minutes to refuel. So considering this, electrical vehicle is going to be your next generation vehicle. Maybe there will be a period of time when there will be no gasoline or petroleum based vehicle anymore. So electrical vehicle is very, very important. This is where you will see that when you connect the electrical vehicle for charging purpose, there may be a imbalance load in your system. And when that occur, you will see that you need some techniques or tools to balance those loads, and that's when your AI applications came in. And if you see which are the countries that is actually employing electrical vehicle or already in establishment, you will see that from this 15 or 12 countries there is in no place for India here, because we are not using the electrical vehicle so much in our countries. So basically, as there is time, we should stop here. There are some more topics are there. Okay. Thank you. If you want to ask the area or where you can work also, you can work. Also, I am working in some of the area that I have discussed here. If you want to work also, you can work with me, or any doubt you want to ask, you can say.
Yeah.